All right, here we go. We're going to talk about integration of logarithmic and exponentials. It's no big deal. You guys already know how to do it. We know the integral of e to the x dx. E to the x plus c. I'm going to change it just a little bit. What about the integral of b to the x dx? Suppose the base is not e. B to the x divided by the natural log of b plus a constant. And the integral of 1 over x dx, natural log of x plus c. You basically already know all these, right? Because you're extremely intelligent. Way to go. Okay, we're not going to go from 3-day, we're going to go 5-day. And we're going to evaluate the integral of 2 over x minus 3 dx. And we first need to start by finding an antiderivative. And so we choose u to be x minus 3. That means du is equal to dx. 1 dx. So I don't have a 1 dx, I have a 2 dx, so therefore 2 du is equal to 2 dx. 2 out in front, integral 5 to 8. What is 1 over u? What's the antiderivative of 1 over u? Natural log. So we get 2 times the natural log of x minus 3 evaluated at 5 and 8. Plug in 8, what do you get? Minus the natural log of 2. Do you remember what you can do with logarithms when you're subtracting like that? Yeah, you can write them as division. So you get 2 times the natural log of 5 halves. There's no plus c because this is a definite integral and not an indefinite integral. So I'm just keeping the 2 out front. I'm plugging in the 8. 8 minus 3 is 5. And 5 minus 3 is 2. Because I have a 2 dx. Now, one last piece, just to show you. I think that this is the way the AP exam would probably write the answer. But please just note that you could take the 2 and write it like this: natural log of 5 over 2 squared. Right? You can bring the 2 up there. Remember that property with logarithms? I know it looks like voodoo math, but so that's the same thing. So anyway, all right, let's try a few more. You guys look like you're ready to go. Looks like you had some really good lunch. Good for you. Okay, let's do B. What do you want u to be? Dx minus 1, so therefore du is, do you have an e to the x dx? I sure do. So therefore, we come up with the integral 2 to 4 of 1 over u du. Now just know, technically my notation is not correct because your bounds wouldn't be from 2 to 4 because you've switched your variable to u, right? But I'm not gonna. Well, I don't. You guys remember when we did substitution of bounds? Like you had to plug the 2 into here, and plug the 4 into here. Technically, that's what we. But I'm not going to do that. We're just going to use the 2 and the 4 when we plug everything back in. So what's the antiderivative of 1 over u? So I got the natural log of e to the x minus 1 evaluated at 2 and 4. So I have the natural log of e to the 4th minus 1 minus the natural log of Very good. Jill sees it. Natural log of e to the 4th minus 1 over e to the 2nd minus 1. And she sees that the top does factor natural log of e squared minus 1, e squared plus 1 over e squared minus 1. And you can see that the e squared minus 1's canceled, so you're therefore left with the natural log of e squared plus 1. But you remember all of your logarithmic properties, right? How about C? X squared, so du is 2x dx. Divide by 2, multiply by 3. 3 halves du is equal to 3x dx. So you now have the integral of 3 halves out front. 5 to the u du. What is the antiderivative of 5 to the u? Five to the u, or 5 to the x squared, divided by 6 and stones. Sticks and stones. What do you think? So, this is a piece that, that's something you've got to be able to think through, folks. It's, natural log of x is an excellent choice because when you take the derivative, you get a 1 over x. I mean, the x in the denominator should really should throw kind of a caution sign for you, being like, shoot, what do we do about the x in the denominator? Well, if I choose u to be natural log of x, then there's no worries about an x in the denominator. Now I just multiply by 1/4. 1/4 du is equal to 1 over 4x dx. So therefore, I have the integral of 1/4 out front. I have u squared du. Antiderivative of u squared. Cubed over 3 plus c, which is, since we have u cubed, it's going to be natural log of x. That is cubed. Whoops, sorry, I meant to put a 12 in the denominator. Jake, you want to buy a table saw? No, I'm trying to make space for the rigid. $7? I would be looking for 100. Because it says take the antiderivative. Haven't I taken the antiderivative of all of them? So, Michael, these are indefinite integrals, so therefore we put the plus c. Whereas these are definite integrals, so you take the antiderivative, then you plug in the 2 and the 4 and you subtract. Got it? Okay. All right, flip it over. I got a Craftsman saw from the late 70s. Solid cast iron top. Passes the penny test. You stand a penny on top of it, turn it on, the penny stays in put, doesn't move. All right. Now let's see who's really intelligent here, because I'm starting to wonder. I know some of you are extremely intelligent. So what would you do for problem E? You just divide through by x. So it becomes the integral of 3x plus 4 minus 2 over x dx. I just divided through by x, or I multiplied through by an x to the negative 1. And now, it's easy. What's the antiderivative of 3x? We just made that super easy, didn't we? Yeah. Not trying to make it challenging, right, Spence? Now, you guys are so smart. What do you do about f? Write it in your notes. What about the integral of x plus 1 over x minus 1? Very good. We cancel off the x's, and 1 divided by negative 1 is negative 1. Right? Yes. Very good. Yeah. I know that's what all you want to do. You're just, No, I'm not serious. Oh, goodness. Square the bottom and the top. Totally illegal, but sounds like a good idea. Well, that would be like saying I could take 2/3 and say, let's just square the top and the bottom. Hey, are those the same? No, they're not. You guys are the best and the brightest, the smartest of all the smarts. What am I going to do, Carter? Okay, you can do substitution. Kind of challenging, a little bit involved. We could choose u is equal to x minus 1 and go to work. I don't know if, what would you do then? Oh, all right. Okay, so that's voodoo math now. But how about we try this? How about I rewrite the integral just like I rewrote this one? So how about I do this? X minus 1, let's divide that into x plus 1. So we're just going to rewrite it. That means divided by. What do you multiply x by to get x? 1. And you get x minus 1. Subtract. What is x minus x? What's 1 minus negative 1? 2. So if the remainder is 2, then I end up with 1 plus 2 over x minus 1, right? Yeah, plus the remainder divided by the divisor. Long division is helpful. It's great. So watch how easy this is now, folks. What's the antiderivative of 1? X. Plus, what's the antiderivative of 2 over x minus 1? Well, let's say u is equal to x minus 1. What's du? dx. I'll multiply by 2. 2 du is equal to 2 dx. So therefore, we have 2 integral of 1 over u du, right? Whoa, 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 whoa. No, just watch. I'm just focusing on 2 over x minus 1. We did the exact same problem right here. It was just 2 over an x minus 3. You had no issue with that. Yeah. Yeah. So let's try this. 7 over 3. Okay? 7 divided by 3. Would you agree that that's 2 and 1/3? So 2 is your divisor, which is right here. 1 is your remainder. Your remainder is right there. And then 3 is your divisor, which is, so your quotient, your remainder, and your divisor. It's all right there. So all I have to do is figure out the antiderivative of 2 over x minus 1. U is equal to x minus 1, so du is equal to dx. So you have the antiderivative of 1 over u. What's the antiderivative of 1 over u? So you just got 2 times natural log of what is u? U is x minus 1. Yes. Right here. What's the antiderivative of 1? Okay, now I'm going to explain why you have to have absolute value signs there in a second, okay? And we'll talk about this one right here, okay? And this will make sense to you. I'm not going to count that right or wrong on the test, okay? But on the AP exam, you're going to see absolute value signs pop up, and I don't want you guys to be scared of that. I'm going to show you why it happens, okay? Anybody want to guess what u is in this situation? 3 plus cosine of x. Because what is du? Right. So you can see that you come up with the sign, right? If you said u is sine, you wouldn't come up with a 3. So negative du is equal to sine of x dx. 1 over u du. What's the antiderivative of 1 over u? So I have negative natural log of 3 plus cosine of x. Now, you can't take the natural log of a negative number. So I want you to think about this. If you plugged a number in for x, could you get x minus 1 to be a negative value? Yeah, what could you plug in for x to make it a negative value? Yeah, 0 would make a negative value. Is 3 plus cosine of x, can that ever be negative? What's the smallest value that cosine of x can be? Negative 1. So can 3 plus cosine ever be negative? So on the AP exam, you would see this listed as just parentheses because it can never be negative. Whereas in this example, you would see absolute value signs. Now, I'm not going to mark that right or wrong for you, okay? I don't care if you use parentheses or absolute value signs. We're not going to get that critical, but I want you to understand that difference, okay? You can't have the natural log of a negative. Last example, what is u? Root of x minus 2. What's du? What's the derivative of the square root of x? 1 over 2 roots of x dx. Do I have a 1 over 2 roots of x dx? No, I just have a, yeah. So I'm going to multiply by 1/2 du is equal to 1 over 4 roots of x dx. I have 1/2 integral of e to the u du, antiderivative of e to the u, e to the u, so 1/2 e to the root of x minus 2 plus a constant. Piece of cake, upside down. I have a worksheet for you, and because we're doing the ACT, you guys, other than juniors, have a full hour tomorrow to work on it.